Okay, good morning. This is math project number 26. Here we go, practice problem 1. The weight of a bowl plus some blocks is 25 ounces. If I add exactly the same amount of blocks to the bowl, the new weight is 40 ounces. How much does the bowl weigh? Okay. Do you understand the problem?
Yeah.
How much does the bowl plus the blocks weigh initially?
25 ounces.
25 ounces. And when I add exactly the same amount of blocks, how much does it weigh now?
It's going to weigh 40 ounces.
Okay. So, we're going to try to figure out how much the bowl weighs. Okay. So, let's erase. Okay, so the interesting thing is we don't know how many blocks are in the bowl. So here's my example of a bowl with some blocks in it. Okay? So what should we call the weight of the bowl?
You can call the weight of the bowl X.
And what should we call the weight of the blocks?
Y.
Okay, so what's our first equation? What's the weight of the bowl plus the blocks in the beginning?
So X plus Y is 25.
Okay, go ahead and write that down. Here, I'll draw a straight line for you to write it on.
X plus Y equals 25.
Okay, try to write straight on the line. Okay? Now, I add exactly the same amount of blocks to the bowl, and the new weight's 40. Okay? Okay? So what do I have now?
Well, now we have...
What do I have that's on, when I put this on the scale, what do I have on this? Initially I had the bowl and some blocks. What do I have now?
A bowl and twice as many blocks.
Okay.
It's 40.
Okay, so how do
So
you...
X plus 2Y.
Okay, so write straight along the line now.
X
Plus 2
Y equals 40.
40. Okay, so my two equations are x plus y equals 25 and x plus 2y equals 40.
I think we could subtract this equation from this equation.
Okay, very good. So can I erase those equations and write them out? All right. So we have x plus y equals 25, which we're going to call equation 1, and equation 2 is x plus 2y equals 40. And what equations do you want to subtract from each other?
So equation 1 minus equation 2.
Are you sure?
Equation 2 minus equation 1.
Equation 2 minus equation 1. Equation 2 minus equation 1. Okay, so you get x minus x equals
0.
Okay, 0. 2y minus y
Y
plus y equals, and what's 40 minus 25?
15.
15. So we know that y equals 15. All right, so very good. Now what was y, the weight of the bowl or the weight of the blocks?
The blocks.
The blocks. So we know the blocks, that first collection of blocks weighs 15. Now how are we going to figure out how much the bowl weighs?
You mean the one at the start, not this one now?
Right, the one at the start, the blocks weighed 15.
Well, if we got twice as many blocks, so 2y is 30.
So 2y is 30, that's right. So how do we figure out what x is?
X is 15 minus 25, which is 10.
X is what?
Well, X is in equation 1.
Okay, so let's not skip steps, because you just told me that 15 minus 25 was equal to 10. That's what you just said. But let's not skip steps. So
That's a negative number.
Yeah. So let's put y equals 15 into the first equation. So we'll go down. So equation number 1 now says x plus 15 equals 25.
So X is equal to 10.
Okay. How do you know that?
I was going to do 25 minus 15.
25 minus 15. And what does that equal?
That equals 10.
Right. So x equals 25 minus 15, which equals 10. Boy, I hope that's on the screen. Oops. Not quite. So x equals 10. Sorry about that. No, I can move it up here. You're right. X equals 10. Okay, very good. You ready to go to the next problem?
Yep.
Okay, here's practice problem number 2. A number has the property that when divided by either 5 or 11, the remainder is 1. What are the two smallest odd numbers with this property? And what is the smallest even number with this property? Okay, do you understand the problem?
Yeah.
We're looking for some numbers, and they have the property. What property? What special property do they have?
When divided by 5 or 11, remainder is 1.
Okay. Now, what do you know more about? Things that are divisible that have remainder 1 when divided by 5, or things that have remainder 1 when divided by 11?
Things that have remainder 1 when divided by 5, it has to be either a 6 or a 1.
It has to end with either a 6 or a 1. Okay. So with remainder 1, when divided by 5, the number ends in a 1 or a 6. Okay? So we'll look for the odd numbers first. So if we know we're looking for an odd number, what's it going to end in?
A 1.
A 1. Okay. Very good. So what's the first odd number you can think of that has remainder 1 when divided by 5?
1.
Does that also have remainder 1 when divided by 11?
Yeah.
Yeah, okay. So we just found the smallest odd number that has remainder 1 when divided by 5 and remainder 1 when divided by 11. It's just 1. Yay! Okay. But that was too easy to find.
Easy.
So now we're going to have to find the next one that ends in a 1 and has remainder 1 when divided by 5 and 1 divided by 11. Now if it ends in a 1, we know it has remainder 1 when divided by 5. So now we just got to count multiples of 11.
So,
And we're looking for we're looking for something that has remainder 1 when divided by 11. So if it ends in a 1, well, go ahead. What's the first multiple of 11?
11.
Okay, so what number above 11 is going to have remainder 1 when divided by 11?
12.
12. Does that end in a 1?
No.
What's the next multiple of 11? So we look,
The next multiple of 11 is 20.
so does 22 plus 1 end in a 1?
No, but I got it.
Okay.
The answer is 110.
The answer is 110? What is
Yeah,
the,
yeah,
the,
'cause-
the answer to what is 110?
Well, that's well, because when you add 1 to it, it ends in a 1.
Okay, so when you add 1 to 110, what do you get?
111.
Which is
111.
111. Does that have remainder 1 when divided by 5?
Yep.
Why?
Because it ends in a 1.
Because it ends in a 1. And does it have remainder 1 when divided by 11?
Yep.
Yes, because 110 is divisible by 11. So the next one is 111. Wow, that was pretty far away. Okay. Now we have to find one. We said find one even number. So now we're going to look for something that ends in a 6 and has remainder 1 when divided by 5 and divided by 11.
Okay, I think another number. It's easy. It's 66.
Boy, it'd be funny if that was wrong, wasn't it? Because you said that was easy. So what is 66?
It's 65, actually.
What is 65?
Well, 65 is divisible by 5.
Is it divisible by 11?
No.
No.
But 66 is.
66 is divisible by 11. So what number above 66 has remainder 1
When divided by 5?
when divided by 11?
11.
What number?
67.
Okay, so does 67 end in a 6?
No.
No. All right. So do you want to guess some more, or do you want to do it systematically?
Let's do it systematically.
Okay. So what's the first multiple of 11?
11.
Okay, 11. And now 11. Does 11 plus 1?
That equals 12, but the
Is
difference
that in a 6? Okay.
No.
So what's the next multiple of 11?
22.
22. Okay. 22 plus 1 equals what?
23.
Is that in a 6?
33.
What's the next multiple of 11? 33.
We just then use into 34.
33 plus 1 equals 34. Does that end in a 6?
No.
Okay. Can you see from the pattern which one is going to end in a 6?
So 44 is going to be 45. It's going to be 55.
Okay, so 55 plus 1 is going to be what?
56.
Okay. Does 56 have a remainder 1 when divided by 5?
Yep.
Does it have a remainder 1 when divided by 11?
Oh, yes it does.
Yes, it does, because 55 is divisible by 11.
So I got 5, 5.
So, no. What's the answer to the problem?
5, 6.
56. Okay, so now let's go back to the beginning of this even number problem. You said the answer was 66. What's the problem? Why isn't 66 the answer?
Well, because it's not the answer.
Well, what's wrong? It has a remainder 1 when divided by 5.
Except you always have to add plus 1.
Okay, what's the remainder when 66 is divided by 11?
1. When 66.
What's the remainder when 66 is divided by 11?
0.
0. And we're looking for something that had remainder 1 when divided by 11. Okay, what did the answer turn out to be?
56.
56. Okay, very good. Good job.
Don't forget about the homework problems.
Oh, gosh. Good job. All right, so the homework problems. Why do I always forget to write down the homework problems? You're good at reminding me. Okay, we're going to do Olympiad 33.
Oh,
I almost accidentally wrote a B.
Olympiad.
Olympiad. Olympiad 33, number 1 and number 2. Okay, so there you go. Those are the 2 homework problems. All right.
Yes.
Yes.